Hey guys, Mr. Backberg here. In this video we're going to look at re-expressing data. Now sometimes as we're trying to come up with a model for our data, it can be helpful for us to transform the data that we're working with by applying some sort of operation to the information that we're given. So taking a look at what we've got data available to us about some different planets and a couple pieces of information about them. One of those columns represents the average distance away from the sun in gigameters, and that other column of data represents the period of orbit, meaning how long it takes for them to orbit, and we're representing that in days right now. What we're actually going to do with this is transform this data a little bit though. And we want to make this data a little bit more convenient for us, and maybe these numbers a little bit easier to work with. So we're going to focus on the information that we know about Earth. And to make this data more convenient to us, we're going to do a little division. And I'm looking at those average distances right now. And we're dealing with Earth being 149.6 gigameters away from the sun. What I'm actually going to do is divide every single one of those numbers in this column by that 149.6. And what that's going to do for us is that's going to give us an Earth distance of 1 unit away from the sun, and those are actually called astronomical units. And then what I'm also going to do is I'm going to look at those days. I'm looking at that 365.2, that's how many days it takes for the Earth to orbit the sun, and we're going to convert this into years by dividing by the 365.2. And we're going to do that to every single entry within this column. And doing those operations is going to give us a new table of data to take a look at. So we've got this new table of data where we've converted those distances into astronomical units, and we've got this new column where we've got our orbits represented in years. And the nice thing about that is as we focus on Earth, we've got a nice 1-1 ordered pair in there. So these average distances from the sun, I'm going to let that be my A variable, and the period of orbit, I'm going to let that be capital T. Now I'm actually going to make one more change with these. Instead of just looking at these as A, T ordered pairs, we're actually going to apply a logarithm, specifically a natural log. So I want to look at the natural log of A compared to the natural log of T. So I'm going to take the natural log of each one of these values. So I've added in a couple more columns. In this column, I'm taking the natural log of all of those A values, those average distances, and in this column on the end, I'm taking the natural log of all of those periods for our orbit. Now I'm going to take these two new columns of information, and I'm going to plug those into my calculator so that I can do a little bit of work with them. So in my calculator, I want to get that data typed in, so I'm going to hit my Stat button and then Edit. In list 1, I'm going to put the natural log of A values from that table. And then in list 2, I'm going to put all of those natural log of T values. Now if I want to get a look at this data, I'm going to hit my Y equals button. I'm going to arrow up and turn plot 1 on, and then I'm going to hit zoom 9 on my graph to adjust the window. Now it looks like this data is making a nice straight line, so we should be able to do a little linear regression with it. So I'm going to go Stat, arrow over to Calc, and go down to linreg number 4 there. I entered my data in list 1 and list 2, so I'm going to go down to Calculate. Now as we take a look at what's happening in here, we've got our Y equals equation with an A value of about 1.5. Now this B value, notice there's a little scientific notation here on the end, E with a -4, meaning that we would have to take this decimal and slide it left 4 spaces. So that essentially gives us a B value of 0. So based on that linear regression, we end up with the linear equation Y equals 1.5x. But now what I want to do is think about what these x's and y's really represent. Those x values were really the natural log of those A values that we were talking about, and the y values really came from the natural log of those t values. Now we're going to do a little work in here using some of our properties of logarithms, and the first thing I'm going to do is divide that natural log of A over to the left-hand side. So then we've got the natural log of t over the natural log of A equals 1.5. Now I can actually use one of my change of base formulas to rewrite the left-hand side, but we're going to be using that change of base formula in reverse. So we can really think about that as log base A of t equals 1.5. Now what I'm going to do with this is switch it into exponential form. So this would say t equals a to the 1.5 power. Now what I'm going to do is square both sides. Now on the right hand side, when we square a to the 1.5 power, you multiply those exponents together, so that becomes a cubed. And on the left hand side, when we take t and square it, we just get t squared. Now this is actually Kepler's third law, where it says the square of the orbital period is equal to the cube of the average distance away from the sun. So by taking that initial set of data that we were given, knowing things about the distance away from the sun and the period of our planetary orbit, we were able to take that and perform some operations on those values and come up with a nice linear equation to represent that data, but then take it and use logarithms to convert it into what Kepler's third law actually states. That's going to be it for this video. Thanks for watching.